Alright guys, I'm just gonna walk you through how I like to set up flex fuel, and if you have an automatic transmission, boost by gear with the Holley Terminator system. So I'm just gonna go through just a little quick setup here. So we're gonna just open a basic file here that has the transition ICF in it and stuff. First thing you need to do is you need to go to your toolbox and add some config files. This is going to be the file that it drops you in here, and we're going to go to IO. You go default IO. That's going to give you this little IO tab up here. And then we're also going to add another config for advanced, and it's going to give you warning, blah 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 blah. This is going to give you your advanced table ICF up here. And so first we're going to go into the inputs here, and we're gonna name this one flex, and we're gonna enable it, and then we're gonna set it to digital speed / frequency, because that's the output the flex fuel sensor puts out. So then we're gonna go into configure, and it's gonna give you some warnings because it's not just set up here, and we're gonna set it to frequency. Now you can set this stupid gauge up any way you want. I just set it up to the max that it puts. Basically, if your flex fuel sensor is working, the way it works is it works on a 50 to 150 hertz range. So the way you're going to read it is basically you subtract 50, and that is your ethanol value. So at 150 hertz, you subtract 50, it would be 100% ethanol. If it's at 75 and you subtract 50, it's going to be at 25% alcohol. I've looked around in the Terminator X. It's not. I can't figure out how to. I know on the HP and the Dominator, I could create this table that converts it for you, and you could log actual ethanol percentage. But on Terminator X, I don't think it has that capability, or I haven't really seen it, even though I haven't looked too much into it. But either way, it's not important. You could change this pulses to average if you have, say, it's in your return system and it runs a little, like if you're on it and you're at the edge of your fuel system kind of, and it basically dries out your return system, and the ethanol percentage drops because of that, because it's not having any fuel flow. You could put this pulses to average up, and it'll kind of help with that, because it's going to take a bunch of pulses and then average that value. If you have this low, it's going to be able to fluctuate a lot faster. So now that we have that set up as a frequency, we're going to back out of here, and then we're going to go to the advanced tables here, and I just like to do a few 1D tables. So we're going to enable the first table, and we're going to put a flex and then fuel. So this is going to be the offset. It's going to offset fuel flow, and then basically it's going to be a multiplier to your fuel table. People argue, oh, this is the right way, you gotta do AFR offset and stuff like that. You could do it, you could try that way. This is the simplest way. It's a standalone ECU. It's not an OEM freaking computer that has to be proper. It's a standalone ECU. However you want to do it it's gonna work. So or that table that we just made, that value is going to be right here now. So it's an input we could use. So flex. So this is you don't really have to check any of this stuff. And we're gonna make this table end at 150, and then we're gonna make it start at 50. And then you could select all these values, and we're gonna fill row value, so it gives us a nice interpolated value. Typically I like to start with oh wait, this is wrong. This is supposed to be a fuel flow multiplier, sorry. Yeah, fuel flow multiplier. So this is going to be a percentage that it's going to multiply your fuel table. Typically as a baseline, I like to my fucking phone's going off. I like to put this at like 35% at 100% ethanol, and then I'm gonna interpolate it through, and then bam, that's gonna give us our base thing for fuel offset. basically you want to run this on E10, which is basically pump gas, and get your closed loop and your learn as close to zero as you can. Within 5% is perfectly acceptable. And then you start adding your ethanol, and from there you're going to see where you're at, and if this needs to be you just change these multipliers to get your desired closed loop down to where it was before you started adding the ethanol. So say we put 50% ethanol in, we're at E50, and we have a multiplier of 18.7% right here, and it's on a little of the rich side, we'll drop that down a little bit of percentage till our closed loop is right, and vice versa. So that's how I set up that. And then we're going to add another table here, and we're going to set this to flex timing. You can name these whatever the hell you want. And this is going to be a timing offset, and we're going to set the flex fuel foot as the input as well. And then we're going to go down here again, do the same thing. We're going to set the max value at 150 and the bottom as 50 because that's the range. And then we're going to interpolate it, and we have a nice value. Typically, you have to... you can set this however you feel comfortable. Usually on the dyno, I just keep adding timing until it stops seeing significant gains when I start adding flex fuel. So, and I usually don't start adding timing until I'm about 40% ethanol. So any positive value you put in here is going to be a timing modifier that it gives you. This is the easy way to do it. This is going to multiply everywhere, and I'll show you a different way that's a more proper way to do it. So say I put 50% ethanol in and I want to add 3 degrees timing. Now it's adding 3 degrees timing. And if I want to put, say once it gets to like E85 value, I want to add another 2 degrees in it, I'd add another 2 degrees here. But this is like a global adder. So you could do this a couple different ways. You could make this so like it's only going to give you more timing when you give it above 60% throttle. So now, or 65% throttle. Now it's only giving you your adder when you're above 65% throttle, when you're in the throttle. Alright, so we're going to set up the boost solenoid. Holley has incorporated boost controller, but they want you to use dome pressure, and honestly for like a street car, I think dome control boost is just a headache. This is great if you want like a drag car that you need to make no pressure out the line or something. You got a big motor but ramp it all in as fast as you can. Dome control works great for that. On a street car, I'm not a fan of it. It's another solenoid, it's another sensor, it's more everything it's more stuff to fail. So, and it costs about 3 times as much as just doing a single 3-port solenoid or a 4-port solenoid. So this is how I set it up, so you can have flex fuel dependent boost control and have gear based boost control using a single 3-port solenoid. So we're going to go to our outputs here, and I already named it boostnoid, and you're going to set it to a pulse width modulated. And then everything we're going to do for setting up the boost solenoid, a single 3-port, is going to be done on this section. So we're going to configure. I usually set a sensor input. We always set this to OR, so if it's either this or that will activate the output. So I set this to a one input trigger, and this is, so I use this off of a TPS. So when the TPS is above 50%, so when you're hammering down on it, the boost solenoid's going to become active. This is just so when you turn on the key, the boost solenoid's not clicking all the time and wearing it out. So that's why I do that. And then we're going to go to pulse width setup. This will be at RPM first. We put this to fixed. This will be at 1. Single 3-port solenoid will like to operate around 31 hertz, so that's where we put it. If you're using a 4-port, I found those like to work better around 19 hertz. If you try to put it higher than that, usually they're real finicky. It's a real finicky solenoid. This is going to be pulse width by default. We're going to set it to duty cycle, and we're going to build a table here. So your access, you could flip flop these. It doesn't really matter. Is going to be the gear that the car is in, and then we're going to do the flex fuel hertz input here. So 50 to 150. We have to scale that. I usually just set these first ones to 1, 2, 3, and 4, and then everything else is it's not going to really matter. Usually just make 4 and above the same. The ECU is not going to really give a crap. So basically, say you have a 7-pound spring in your car and you want to run it on pump gas, say 10 pounds, and you find that 10 pounds at 30% duty cycle on the solenoid. So this is going to be your 0 ethanol, and basically these last 2 columns is going to be pump gas, because most pump gas is 10% ethanol these days. And you want to run around on only 10 pounds when you're on pump gas. Cool. So you found that at 35% duty cycle. Now we have 35% duty cycle through all the gears, and that's your pump gas section of the tune. This could vary. Maybe you want 10 pounds in first gear, and you want you found 12 pounds at 38% duty cycle in second, and you want 15 thereon, and you found that at 42% duty cycle, and then now you have it set up by gear. And then you start adding some more ethanol, and you get to 50% ethanol, and you want more boost. So now you want to run 14 pounds in first gear, and say 16, 17 in second, and then go for the Hail Mary in third and fourth, and you can ramp up boost that way. This is going to reference every way you do it, and then we're going to interplate it between the duty cycles. So now you have a table built that's going to give you variable boost based on ethanol content right here and what gear you're in. So I set this up on a car the other day. It worked very well. It's nice. You don't have to push no buttons. Don't have to worry about nothing. You just have to run 2 wires. You use 1 input, 1 output, and you have boost by gear and flex fuel dependent boost. Now these are just all random values I threw in here. You're gonna have to, like, if you're on the dyno, you're gonna have to lock this out at a certain percentage, and build on what you've got to build a table basically on what boost you want to run, because this all translates into duty cycle. There's no closed loop or anything like that. That's one of the advantages you get using the dome control. I hope Holley certain in the future gets rid of that, because I think it's pointless on a budget-minded system to have only option of boost control as a dome control setup, which is expensive. So, but there you have it. That's how I like to set up these things. Alright guys, now I'm going to show you how to set up boost versus time with the single 3-port solenoid. So let's go. First of all, we're going to need to go into the boost config here, and we're going to enable the launch input. You're going to have to wire, either if you're a trans brake car, you're going to have to tie in the trans brake. Don't tie in the trans brake like just adding a wire. If you have to have some sort of flyback protection, Holley sells a little module for this, just so you don't burn up the ECU. So we're going to check this box, go to inputs, outputs, and we're going to define the launch button. So this is whatever you're going to run, 12 volt or ground, and then you're going to have to add it on the pin map. I just threw it to a random input. And after that, we're going to go into our IO here. We're going to go to outputs, and we already created a boost solenoid here output. That's a pulse width modulated. It's enabled. I already have it for above 50%. I was doing this for the automatic tranny, but this now we're going to do fixed here 31 duty cycle boost time. So this is going to go off of when you release the trans brake that we just defined. So I mean, realistically, you don't need this more than 5 seconds here. Everything past 5 seconds, you're gonna just be in it. I don't really see the need for flex on this, because this is probably going to be a drag race application. If you're using boost versus time, it's going to be only track kind of thing. But it's whatever. It's just the access we're going to go off of here, because I was using this to set up a boost by gear on an automatic tranny vehicle based on flex. I mean, I guess if you want to run it on pump gas and run it on ethanol, it'll still work. You're just gonna have to go by these values. And then it's pretty simple. Whatever, say you're making that 65% duty cycle on the wastegate, you're making 15 pounds, and you want to ramp into 15 pounds in 2 seconds. So 65, and then you can use this as a boost builder function. You can just put 100%. It's going to slam the wastegate shut. And then as soon as you let go of the brake, usually put this at like a 0.1 of a second, it's going to start your ramp. So say you want to ramp in at 25% duty cycle, but you want to be full in by 2 seconds, which is a pretty weak ass ramp. Maybe you're doing some whack ass no prep shit, but I'm not going to judge you. And then fill the roll values, and then now you have a nice ramp to go in, and you can adjust this however you want. And this is going to control single 3-port solenoid, as to oppose doing the dome control and stuff like that. That's how I set it up.